Alright, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So today we're going to start a new topic, which is chapter number 2, estimation. So the learning objective, I just go through very fast. First is to describe the point estimation for mean, variance, and proportion. Second is to identify the method to get an estimator. Third is to define a good properties of a point estimation, and last is to find the interval estimation. Right, after you complete this chapter, you should be able to describe the point estimation, identify the method of to get an estimation, define good properties of point estimation, and find interval estimation. Right, for introduction, estimation is a numerical value assigned to a population parameter using a sample statistics, right? So you need to remember, we do a estimation and we are dealing with the sample statistics. And the procedure of estimation are, first we need to select a sample, collect the data, calculate the value of sample statistic, and assign the value to a corresponding parameter, right? So a statistic used to estimate the value of parameter is called as estimator, right? So statistics used to estimate the value of parameter we call as estimator. So this is estimator. We make it clear. Estimator for mu population mean is x bar, and the value of the x bar is 1.43. This is what we call as a point estimate. So this is a estimator, right? So type of estimation, we have two types of estimation. First is a point estimation, and then the second one is interval estimation. For today's lecture, we will learn about point estimation. Right, point estimation is based on the sample data. It has only a single number or two number calculated to estimate the population parameter. So the rule or formula that described in this calculation we call as a point estimator, and the resulting number we call as a point estimate. Again, this is a point estimate, and this is point estimator. And this is point estimate, right? So interval estimator, based on the sample data, two numbers are calculated from the interval within the parameter is expected to lies. So interval estimator, in other words, we call as a confidence interval, right? We have two value. This is a lower value, lower confidence limit, and this is the upper confidence limit. So we are going to have two value, but that's why we call as interval estimator. Any number lies between these two value are possible. Right, additional information. Let's say we want to estimate the parameter theta. A statistic used to approximate or estimate the parameter theta is what we call as a point estimator, denoted as theta hat. So theta hat is a point estimator, and the value, let's say 1.43, this is what we call as point estimate. This is a point estimator. So I already repeat this many times, right? So I hope you understand what is the difference between point estimator and a point estimate. Point estimate means the value corresponding to the point estimator, right? The point estimator is the parameter that we're going to estimate for the population parameter. So this is a table of point estimate. So let's say the target parameter is mu, right? And the sample size is n, and the point estimator is x bar, right? And the standard error is sigma divided by square root of n. So this is the standard error. For a proportion, if you want to target, if our target parameter is a proportion and the sample size is n, and the point estimator is p hat, right? And the standard error for a p hat is square root of pq divided by n, right? So the next third row and the fourth row is target parameter for two population, mu1 minus mu2, and the point estimator is x bar 1 minus x bar 2. This is you already look at into QMT 161, I think, right? So example, again, I just emphasize what is the difference between point estimator and the point estimate. Suppose a college president wish to estimate the average age of the student attending class this semester, right? So the president could select a random sample of 100 students and find the average age of the student. So let's say the average age of the 100 student is 22.3 years. So this is a point estimator again, and this is the point estimate, right? I just want you to be clear what is the difference between point estimator and point estimate. Right. So another example, let's look at this example. Right, a sample of 35 observation is taken from the population as follow. So we have 35 observation, right? So the question is, what is a point estimate for mu and sigma squared? So mu, we know that mu is the mean of the population, the sample, right? So let's say mu hat is equal to x bar equal to summation of x divided by n. So the value of summation of x is equal to, let's say, 1342 divided by we have 35 observation, right? And then this is going to lead us to 38.34, right? So the point estimator for mu is x bar, and the point estimate is 38.34, right? And then for sigma squared hat is equal to s squared. So this is a sample variance, which is equal to 1 over n minus 1 summation of x squared minus summation of x, and then you square divided by n. This is a formula for sample variance, and once you plug in the value, let's say 1 over 35 minus 1, and then summation of x squared is 5155.4 minus 1342 power of 2 divided by 35. Right? So this is going to be 2.88. So this is the point estimate for the sample variance. So this is a point estimator. So are you clear with this one? If you clear what is the difference between point estimate and point estimator, can you comment on chat section? All right, good.